we're back coding in the kitchen again, different kitchen, different country. This time we're building on what we did with the Catmull ROM curves and doing generative drawing and then using plotters to make some generative art with plotters. It is a ridiculously beautiful day. I'm back in the forest for a couple of days. We just had some snow come in. It's gonna be spring next week. And I want to carry on with generative drawing and get away from the screen a little bit. So we're gonna go into the workshop, dig through all of the weird random electronics, because somewhere in here we have a plotter. So we're going to do some generative plotter drawings on art and code, and we're probably going to end up in the kitchen again. Let's see. Whether we can find it in here. Well, either of them. I've got a couple. So let's dig in. This time I'm going to be hunting for the plotters, and then we're going to connect them up, and we're going to see if we can make them work, and then we're going to get them to do some drawings with us. So I'm in the studio, I'm in the workshop. Let's make some generative drawings. There's number one. There's number one. Roland DXY Plotter, DXY 1300, piece of 1980s weirdness. And somewhere in here, there's another one. So we're going to dig through. I know one's got a power supply and the other one doesn't. And then I need to find a box of pens. And we're gonna do some drawing. And bear with me, it's here somewhere. There we go. 2 plotters. And I think this Roland DXY 980 pens, plotter arm, static electric bed, which is kind of really cool. You sticks the paper down. So we're going to drag this in, do some coding in the kitchen, and so got two plotters. Got the smaller DXY 1300 and the larger Roland down here. Found me a power supply, might need to change the plug, can sort that out. I'm gonna drag it all out and maybe go somewhere a little warmer because we're still in winter here. We had snow yesterday, a little bit cold, so coding in the kitchen. To talk to it, we're using this old style serial cable. Which has an RS-232 on the other end. So I have this serial to USB adapter to USB-C. And all of this goes together and in to the back of this. All done. Let's plug it in, see if it still works. On the back, we have power, parallel interface in, a serial interface in that we're going to use, and then these dip switches. And the dip switches allow us to set different speeds that we communicate at and the different modes that the machine will run on. And this is what we used to have to do manually. So the serial cable is plugged in, serial to USB adapter, going to USB-C, everything is powered up. And I've got the plotter here, I've got a whole bunch of stuff set up, and I've had this running before. So the serial interface cable is plugged in. It has to go in through USB, etc., etc. I've got the power supply set in. I've just done the self-test and everything is working fine. Really, really happy. You can see the self-test like going on right now. So if I do the self-test, I need to fire the machine up and hold down the enter key at the same time, and then it'll go through doing a standard self-test. You can see the XY plot moves around and then it lifts the pen head up and down. I've just got one colour in at the moment, but we've got a box full of old colours and it seems to be working absolutely fine. So I've set up the dip switches on the back that you saw earlier and it's communicating fine, it's running fine, and I have been able to find the manual. So I have this as a PDF download, which gives me all of the settings, all of the descriptions, the material about self-test. One of the challenges was talking to it, and I found a couple of different places when I got this, which was an eBay special. I found a couple of different projects that had got old plotters, some pieces on YouTube, and this from Hackaday.io was really useful for a discussion of what they'd found to work. Walking through the self-test, their descriptions of the hardware setup. When I started digging around to realize that this runs HPGL, I found this project from Dan Moore. So Dan Moore, thank you very much. And this is 7 years old, but the code still runs. And this is an add-on for openFrameworks called OFX MH871 that he built to make an MH871 vinyl cutter work, but that also talks Hewlett-Packard graphic language. So I have the add-on, I've downloaded it. I also need the OFX timing add-on, which I've downloaded and put in my add-ons folder. And then I need to find out what port the serial device is attached to. So I can run this command in terminal, ls list dev tty, and then anything with a wildcard character. So if I run that now, I can see a couple of things that are attached, and here it is. Dev tty serial USB serial -10. So that's really cool. I know where this thing is now. So when we write our code in openFrameworks and we want to talk to it, that's where we talk to it. So I've made a new openFrameworks project, and in the project generator setup, I've added the OMX MH871 and the timing add-on, so we can now talk serial out to the plotter. And in the setup, because I want to draw stuff onto the screen here as well to the plotter in lots of different colors, I've just made a list of colors, and I've set up some basic things, a grid, a margin that I want to draw around, and I've made an MH871 plotter object. And whereas previously I was drawing straight to the screen with a dot, I'm going to make a line object. So I'm going to use OF polyline that I can then put lots and lots and lots of points in, and that'll generate the data that I can then send to the plotter, and it will remember or be able to read out the points in an XY axis that make up all my lines. So in my CPP file, all I've done is I've set the background color and the window size, and then I've just made a list of colors that I'm pushing into this vector, and that's just so that I can draw to screen easily. I've set up a grid because what I'm going to do is I'm going to take the polyline, and instead of squiggling all over the screen, I actually want to make it draw one and then another and then another and then another and another, so I get a grid of swirls, and you'll see this in a minute. I've set the background. And then here is the bit where I ran that command earlier to list out all of the devices that we can see on USB. And the one that came up I'm using is this USB serial. Depending upon what printer you've got added or plotter you've got added, it'll be slightly different. In my update, I'm just telling the plotter to keep updating in case it's doing something. And then in my draw loop, I'm saying take the polyline and draw it, and also sending the same command to the plotter. And I've set up a couple of things in the key presses so I can toggle it full screen. When I press the P key, I tell the plotter to plot out this polyline called line. And when I press the D key, this is where I make my line. And I'm going to use this curve2 command. And the first thing that I'm going to do is I'm going to take my line, my polyline object, and clear it, empty it out. And then I've set up 3 loops inside each other where I'm saying make 7 curves. X is 0, x minus 7. And I'm then going to set up a bunch of x and y coordinates just using random. And then I take those x and y coordinates that I've built to say in the line object, curve from the beginning or wherever the last point was to this new XY position. And then I'm just repeating across the width of the screen. So I'm getting the width of the screen, taking off the bit of margin that I set up earlier. And then I'm going to add in the grid size that I've set to say how big across the margin do I want these squiggles. So it'll draw me multiple squiggles. And then when I press the space bar, I'm just going to clear that polyline object that I made. So let's build this and have a look what we've got on screen. And down here in the debug, you'll see this is really cool. OF serial is opening and it's successfully talking at 9600 bits per second. So here's my drawing area, and if I press the D key, it's using curves to link all of these points. And if I come and change my grid size, compile this again, tell it to draw, you can see it's taking the width of my drawing area, taking off the margins and working out how many pieces I can put in there. Let's print something. I've got paper in, I press the paper hold button. I'm going to run my code, hit the D key. I've got a drawing, I don't like that. This one, I like this one. So if I hit the P key, it should start streaming commands to the plotter, and there it goes. So you can see it tracing the data that it's sending to the plotter. You can see where it's firing the data out. So there's my drawing. There's a couple of things I'm going to do. First of all, I'm going to go back to the grid size and say, actually, what I want is more of these squiggles. So across the width of my drawing area, I'm just going to say make a smaller grid. We can see there's a drawing. And I'm kind of liking what's going on. So let's load up some fresh paper and do some more drawing. And off we go. Drawn all the way through to the end, and if we come to the drawing cam, you can see it's followed each of these. Occasionally it's overrunning the buffer and it's missing some points. If I send that home, so you can see there are occasionally pieces of glitch where it's missed out a portion of the data because we're firing the data to it too fast, but I'm not going to worry about that. And I think we should get going and do some more. So I'm just going to keep running drawings here and try some different things out. And I'll put the windows side by side so you can see what's going on. The code is super simple. So once we've got this going, you can draw anything into a polyline and send the data out to a plotter. So keep an eye out on eBay and you may be able to pick one of these up as well. So we've done a couple of plots and I want to change the speed. So let's quit this and come and set the frame rate back to 30. And let's just run it some more and see what we get. And I'm going to change the pen color, put some new paper in, and just keep running and running and running. And maybe at the end of the day, if you want one of these, leave me a comment and I'll send it to you. I'm going to keep the grid size the same, but I'd like to randomize this a bit because it's very, very irregular. So when we tell it to draw, it's always drawing. There's 9 figures, always in the same handedness. So I'm going to come in and say, "20% of the time, skip one of these." So if we run it, we're getting a lot more variation, which I'm really liking. And I think what I might do is put a couple of these figures together in multiple colors. So draw one, swap the pens, draw another, swap the pens, draw another, and see what happens when we start layering. So I think I'm gonna draw that right now. So send it to drawing. That looks kind of nice. I'm going to swap the pens and run it again. So we've been drawing all day, and some of these I really like. I like the simplicity of it. I'm also quite confused by it. I love working with a plotter. I love doing physical things. And I love the patina, the graftiness of it. It reminds me of another project about doing robot drawing. Maybe I'll make a video about. But I'll put the code online. You can get it from GitHub repo. If you're doing plotter stuff, send me a link. I'd love to see what you're doing. I know people are doing all kinds of things. I love this because every single drawing is going to be different. And also then the plotter adds this gruftiness to it, the shakiness to it, the dirtiness to it. And I think maybe I'll do some more experiments, drawing with graphite pencils. I've done it with big fat felt tips, and you get lots and lots of different expression in the marks, which I really like. Anyway, we're back, coding in the kitchen, art and code. Please hit the subscribe button, and I'll see you on another video.